Okay guys, I hope you had fun yesterday learning how to build your own coordinate planes and figure out which is the x-axis and which is the y-axis. Today we're going to talk about line graphs. You've probably talked about line graphs before, but we're going to build these line graphs on our coordinate planes, and we're going to identify an x-axis and a y-axis. Remember, we talked about yesterday about how the x-axis is always going to be the intervals, and the y-axis is always going to be the measurement. When you're making a line graph, you only do this, you only draw the lines between the data points when you're tracking changes over time. So remember yesterday we looked at the kid's height and we said how tall he was when he was 1, when he was 2, when he was 3, when he was 4. That we could turn into a line graph because we're tracking his height over time. Okay? However, if I'm going to look at different heights for different people, then I'm not going to make it into a line graph. So the line graph, it has to be something that shows change over time. All right, you have to label your graph just like you labeled your coordinate plane. And you also have to label the scale. Our intervals of how we count, that's our scale. You have to make sure that you include that. Okay, and you have to make sure you include the intervals. So here we have recorded temperatures, and we're going to look at the time, and then we're going to look at the temperature. And this is in Fahrenheit, so it's not super hot. This is actually pretty normal spring weather. It's a little bit warmer than what your weather currently is, but not by much. So it's a typical spring day, and it's recording the temperature. So we're going to identify the time as being our x, and temperature is being our y, because temperature is dependent on the time, and that's what we're measuring. And we know that we're measuring it because it tells us we're measuring it in Fahrenheit degrees. Okay? So our first ordered pair is 1 o'clock and then 51. Our second one will be 2 o'clock. I'm going to put little zeros because I can't draw big ones. And then it's 49 degrees. Okay? The next ordered pair, we will have 3 o'clock, and it will be 47 degrees. Do we notice what the trend is so far? Hopefully you notice that as the day goes on, it is getting colder. So when I said it was a typical spring day, it actually might be kind of a typical fall day. At 4 o'clock, it is 44 degrees. And at 5 o'clock, it is 45 degrees. Okay, getting a little bit warmer there. 6 o'clock, it is 44 degrees again. So we're kind of hovering right about here. A little chilly, you need a good sweatshirt. And then our last one is 7 o'clock, and it's 46 degrees. So it was a day that started off nice and sunny and warm and ended up kind of chilly. So our x-axis is the time, and we have to put our interval 1, 2, 3, 4, 5, 6, and 7 o'clock. Then we have to put our temperature here on the y-axis. Notice this funny looking thing right here. This shows us that we're going to jump numbers. And we're allowed to do that because our numbers are between 44 and 51. So we don't really need to count from 0. If we started 0, 2, 4, 6, 8, our 50 would be way off the screen and it would be a giant map. But all of our data is in this section. So we show this to say that we're skipping the numbers 0 through 40. Okay? So it's letting us know. If we didn't have this little jujab thing, then it would be counting by 40, and then the next one would have to be 80, and then the next one would have to be 120. Okay, so we have all of our coordinate pairs. Let's look over here. It says, for the vertical axis, choose a scale and an interval that are appropriate for the data. You can show a break in the scale between 0 and 40 since there are no temperatures between 0 and 44. And that's what we mean here. We show the break. And this is vertical. Up and down is vertical. So this up and down vertical, up and down, up, down. Okay. For the horizontal axis, write the times of the day. And then you make sure that you title both of them, temperature in Fahrenheit, time, AM. Where did these titles come from? They're right here, time, AM, temperature in Fahrenheit. So you just simply copy that over. And then you draw a point. So 1 o'clock, we have 51 degrees. 2 o'clock, we have 49 degrees. 3 o'clock, 47 degrees. And then at 4 o'clock, we have to go to 44 degrees. 44. 5 o'clock is 45. So we're in the middle here. And then 6 o'clock is 44 again, back here. And then 7 o'clock is 46, up to here. Got a little bit warmer. And then, because this is showing over time, we're going to draw lines. Oops. Okay, hopefully your line is a little bit better than mine. There we go. Right, ignore the little triangle, that doesn't count. All right, so you draw your line because it's showing how the temperature has changed over time. It's looking at how it's changed over the course of 6 hours. So we draw the line because now we can visually see that temperature plummeted down and then it went a little bit up and down and kind of stayed, but still it ended the day colder than it started the day. So let's look at each line segment in the graph. Find the line segment that shows the greatest change in temperature between two consecutive points. So you're looking between here and here, between here and here, here and here, here and here, here and here, here and here. You're looking for where is the greatest change. So here is at 51 and here is at 49. So this is -2. 49 to 47, this is again -2. From 47 to 44, that's -3. For 44 to 46, that's +2. Or sorry, to 42 to 44. Yeah, 44 to 45. Sorry, I can talk. 44 to 45, that's 1. That's a 1. And then again 1. And then 2. So which interval had the greatest change? The greatest change is the one that has the 3, because the rest are 1s and 2 degrees. So the greatest temperature change occurred between 3 o'clock and 4 o'clock. Between 3 and 4 a.m. Okay. All right, let's go on to the next page. Same thing. Jill used a rain gauge to collect data on the total rainfall during 6 days at her home in Miami. She read the amount of rain collected in the rain gauge each day and did not pour it out. Her data is shown in the table. And then we're going to make a line graph. The reason why we're making a line graph is because we're looking at how it is over time. Okay? So first we make our ordered pairs. And this is interesting because we don't have data to use for our X. Our day is X, and rather than saying day 1, day 2, day 3, we're actually giving the days of the week. So it's going to be Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. This is a U. There you go. Alright, so Monday was at 2 inches. Tuesday is at 2 inches as well. They didn't get any rain. Wednesday is at 3 inches. Make that look like a W so you can see. You should actually write W-E-D and T-U-E, just I can't because my cursor's too big. Thursday is at 6. It rained a whole bunch that day. Friday at 8. And Saturday at 9. Okay, so we're going to look at choosing a scale. All right, and our numbers are ranging between 2 and 9. So when there's this little bit of a range, it's best to go ahead and count by 1. So we can count by 1, 2, 3, 4, 5. Get the idea? 6, 7, 8, 9, and 10. Okay. And then we need to have down here, we're going to put Monday, skip 1, Tuesday, skip 1, Wednesday, skip 1. I'm going to write an R for Thursday, skip 1, Friday, skip 1, Saturday. Okay. And then these you would write day. And then over here you write rainfall in inches. Okay, rain. Go ahead and write rainfall in inches. This is what you write. Okay, this is what you write, and your title is rainfall collected. Okay, again, I can't write with my thing. I'm trying to hurry up so that way I don't run out of time because it cuts me off at 15 minutes. Okay, and we're at 11:30. All right, so rainfall collected, you would keep doing it. And then we just graph our ordered pairs like we've done before. So go ahead and graph your ordered pairs. I'll graph them up here. Check your work. Mr. Will come around. Monday 2, Tuesday 2, Wednesday 3, Thursday 6, Friday 8, and Saturday 9. And then because we're charting over time, we're going to draw lines between them. Okay? And then we can answer the questions. On which day was the total rainfall recorded the greatest? Well, that's easy. Which one is the highest? That's Saturday. And then on which day did Jill record the greatest increase in rainfall collected from the previous day? We can look at our graph and we can see this is going by 1, this is going by 2, this is going by 1, 2, 3, this is going by 2, and that's going by none. So here's our greatest right here. And so that's between Wednesday and Thursday. Wednesday and Thursday. Okay, Wednesday and Thursday. All right, so finish up your graphs really fast. If you need to, Mr. Will, go ahead and pause this and let them put their work down. I'm going to move on and delete it, so pause if you have to. What I would like for you to do is please go ahead and do numbers 1 through 4 on your own. Pause this while you are working. Come back and check your answers. Okay, so you should have said that the best scale would be starting at the number 40 and going through 70, which means that you have to show a break from 0 to 40 on your data set. Okay, I thought that counting by 5s would be best, so you'd have 40, 45, 50, 55, 60, 65, 70. That would take up most of the space and allow us to see our change. And then your x-axis is going to be the months. You need to make sure that down here you actually write the word month, and along here you actually write temperature in Fahrenheit. Your ordered pairs, I wrote one for you, January, 40. Make sure you put in parentheses. You should write each one of these as an ordered pair, January 40, February 44, March 54. You make your line graph. I started it. It would continue to go up until you got to 70. And then it's the least change, which is January through February. January through February. All right. If you understand this, go ahead and start working on your homework, 9.4. If you need some extra help, Mr. Will do one on the board for you, this number 5 through 8. Okay.